Welcome to Ask and Learn.
So as in this problem, we have to find out the Z equivalent through these 2 points. So we have to find out the value of Z equivalent, and the given values are given over there. So the value is, this is 4J ohm and this is minus 2J ohm, right? So we have to find out the equivalent impedance across these 2 points. Let's suppose this is point A and this is point B. So we need to find out the Z equivalent. So as you can see, this 2 ohm and this 4J ohm are in series, so we can directly add them. So if I redraw the circuit diagram, what I can do is, this is 6 ohm, and if you, let's suppose this is these are also in series, so we can also draw equivalent impedance of these two by simply adding both of them. So I'm just going to add both of them, and this will become 1 minus 2J impedance across this branch, and then impedance, as these are also in series, so we can simply add both of them. So let's suppose this is the second branch, and the equivalent impedance will be 2 plus 4J, right? So this is the impedance across this branch, and this is the impedance across this branch, and this is the 6 ohm, right? So let's suppose the equivalent impedance across these two is Z1. So the value of Z1, you already know that the equivalent impedance, if the impedance are in the parallel, so we have the formula for the Z equivalent, which is, let's suppose the two impedances are in the parallel, so the Z equivalent will be, let's suppose this is one of them is Z1, so and another one is Z2, and the value of Z equivalent will be Z1 plus Z2. This is the formula for finding the equivalent impedance if the two different impedances are in the parallel combination, right? So if let's suppose, or this is our Z equivalent prime, right? So and then suppose this is our Z1 and this is our Z2. So Z equivalent prime will be, can we write it as Z equivalent prime is equal to Z1 Z1 into Z2 by Z1 plus Z2. Now let's put the values given the circuit. So Z1 is 1 minus 2J. So this will be 1 minus 2J multiply with 2 plus 4J, that is Z2, 2 plus 4J. And after the summation of these two, so this will become 1 minus 2J plus 2 plus 4J, right? So we will get it, if we simplify it, what you will get is, this is, just multiply both of them and add these two. So if I multiply, I will get 2 plus 4J minus 4J plus 8, right? So this will be plus 8, and the denominator will be 3 plus 2J. So as these, both of them will be cancelled, so the value will be Z equivalent dash will be 10 by 3 plus 2J. And if we multiply with the conjugate, what we will get is 10 into 3 minus 2J, and in the denominator you will get 3 square plus 2 square, right? So this will become as 10 by 13 3 minus 2J. So this is our Z equivalent prime. So we have to find out the Z equivalent. So as you can see, if I redraw the equivalent circuit, what we will be found is, this is our 6 ohm and this is our Z equivalent prime. Z equivalent prime. So the final value of the Z equivalent will be summation of these two. So the Z equivalent will be 6 ohm plus summation of Z equivalent prime. So this will become as 10 by 13 3 minus 2J plus 6 ohm. So if you simplify, you will finally get it as, the value of Z equivalent will be 8.31 minus 1.54J. So this is the final answer. The Z equivalent will be 8.31 minus 1.54J. This is the final answer.